Welcome to the final video of this week. We're going to talk about some applications of logarithms. Nothing too crazy, nothing too heavy. We just some light applications. Applications light, L-I-T-E. Example 2. Y equals 2x squared minus the natural log of 4x has one local min. Oh yeah, more chapter 2. And again, this video really is nothing really crazily new. I'm just doing these problems to give you guys some more exposure, give you more examples to look at if you want. You may already be able to do the section, okay? That's the beauty of an online class, is it's really up to you kind of how much time you spend watching things, how much time you spend doing things, and finding the balance that works for you, and then asking questions as well is great. Anyway, local min. So notice here, I'm already telling you there's a local min. We don't need to classify it here. We don't need to use a derivative test. I'm telling you it's a local min. We just need to find it. So we're really just going to find the critical point, which is when derivative equals 0. So derivative of this is going to be 4x. The derivative of the natural log is the reciprocal. 1 over 4x. Reciprocal of the inside. But chain rule says we have to multiply by the derivative of the inside, which is 4. Okay? And we need to set this equal to 0. So this is going to be 0, 4x. Oh, we got some really nice stuff here, right? Multiply by 4, divide by 4. 4x minus 1 over x. Whenever you have fractions and you want to solve an equation, multiplying by the LCD is a very good idea. Okay, so that LCD, there's only one denominator. Multiply the left-hand side by x. Multiply the right-hand side by x. Left-hand side is something really nice. 0 times any finite number is 0. Second x we're going to distribute. We'll get 4x squared minus x over x. Those cancel to 1. Hey, there we go. Something real nice here. Let's add 1 to both sides. Let's divide by 4. Let's take the square root. We'll get x equals plus or minus the square root of 1/4, just plus or minus 1/2. Uh-oh. Danger alert. There's only supposed to be one local minimum. How come I found 2? How is that possible? There's not 2. Let's look at this function. What's the domain of this function? Remember, we can't take the natural log of 0 or any negative numbers. The domain of the natural log function is 0 to infinity. So this minus, that's not in the domain. All right. So we're going to throw out the negative. The local min is only when x is equal to positive 1/2. And y will be, you'll have to type that into a calculator. It'll be 2 times 1/2 squared minus the natural log of 4 times 1/2, which would be negative 0.193. So the local min is at this point. And x is equal to that, and y is equal to that. And that should be the answer. Don't believe me? Let's look. Here's the function. Where's the local min? There's a local min right there. 1/2, negative 0.93. Hey, we did it. All right, that's great. So we know we're right. Let's do another one. One last video to end this week of 3 sections. It's going to be example 3. If demand is given by this demand equation, P equals 45 divided by the natural log of x. Determine and interpret the marginal revenue when x equals 20. This is really combining a lot of different sections now. Okay. Couple things to think about. Marginal. Marginal means derivative. The marginal revenue is R prime. Okay. But to find the derivative of the revenue, first we have to find the revenue. We don't know the revenue. We need to find the revenue. Remember what demand equations are all about. Demand equations say, if I want to sell X things, I have to charge P price. So if I want to sell X things, P is the price each one of them has to sell for. The demand equation is just the relationship between what price P that I charge and how many people are going to buy them. The more I charge, the bigger P. The fewer people are going to buy them, the smaller X. Okay? So the revenue, if I'm selling 20 balloons for $3 each, I make $60. Just multiply, what's the price? How many am I selling? What's the price? How many am I selling? Revenue is always the price times number sold, XP. All right. Well, what is P? Well, we have it up there. The price is going to be 45 divided by the natural log of X. And we're multiplying that price P by X. Be very careful. Do not cancel. Right? Anything inside a logarithm cannot cancel. It is isolated inside. And we need to take the derivative of this. We could rewrite this a little bit if we wanted to, or we could just get derivating. We could write this as 45 times x over ln x. We'll have to use a quotient rule when we take the derivative here. Again, we want marginal revenue. Marginal revenue is derivative of the revenue function. It'll be r prime of x. The 45 comes out in front. We have to use a quotient rule. Low, d high, minus high, d low. Derivative of ln is 1 over x. Square the bottom, and away we go. That whole fraction is getting multiplied by 45. 45 is in front. And what are we left with? Ln x. We get some cancellation right here. Remember, things cancel to 1 over the natural log of x squared. And it doesn't really simplify from here. So we specifically want to find the marginal revenue. Marginal revenue when x is 20, when we're producing 20 units. Let's go down here and plug in 20 over here. R prime of 20 going to be 45 times the natural log of 20 minus 1 over the natural log of 20 squared. I believe that's what we had. All right, and that's going to come out to some number, which we'll plug into our calculators. 45 times the natural log of 20 minus 1, all divided by the natural log of 20 squared, is about 10.01. So the marginal revenue is $10.01. So that means when we're producing $20 units, if we produced an additional unit, that additional unit would give us about $10 more. All right. That's what marginal revenue is all about. An additional unit yields about $10 extra of revenue. Marginal cost at a given production level. Increasing production by 1 is going to add that cost to it. Marginal revenue. Increasing production by 1 adds that revenue. Okay? That's what we've got here. That's the answer to this question. Let me know if you have questions. Congratulations on surviving the triple week. You have an exam week the week after this one, but we did 3 today so that we only have to do 1 on the exam week and hopefully make your exam week a little bit easier to prepare for. Good luck and bye-bye.